Assalamualaikum and hello everyone. Welcome back to chapter 5 Vectors. In this video, we will proceed with 5.4 Application of Vectors in Geometry, Part B. Determine the angle between two straight lines. Given two lines are r equal to a plus t v1 and r equal to b plus lambda v2, where t and lambda are real number, the angle between lines 1 and line 2 is defined as the angle between direction vectors v1 and v2. By scalar product definition, we're going to have the angle equal with inverse cos of v1 dot v2 divided by magnitude v1 times magnitude v2. So there is a remark there. So when v1 is perpendicular to v2, we're going to have v1 dot v2 equal to 0. And if v1 is parallel to v2, we have v1 cross v2 equal to 0. So let's try example 12a. The vector equation of two straight lines are given by P and Q. Find the acute angle between two straight lines. So first of all, you have to identify your V for both equations. So from P will be V1 and from Q we have V2. So your V1 will be I plus 3J minus 3K. And then the V2 will be I plus 2J minus 4K. So next, you have to find the magnitude for both vectors. So magnitude V1, we're going to have square root of 19. Magnitude of V2, which is square root of 21. Then, we have to find the dot product of V1 and V2. So we're going to have 19. So now we already have it all the values. So you can substitute into the formula, which is inverse cos of the dot product, which is 19 over magnitude V1, magnitude V2. So we're going to have the value which is 17.98 degree. Okay, example 12b. By given three equation of lines, part A we have to show that the line 1 and line 2 are parallel. Part B we have to find the angle between line 2 and line 3. So take a look for part A. So for line 1 and line 2 are parallel, it's mean your V1 and V2 are parallel as well. So as the remark on the previous slide, we have V1 cross V2 must be equal to 0 for the properties of parallel. So before we find the cross product, you have to find out the V1 and V2 first. So your V1 will be 2i minus 2j plus 4k. And then for the V2, we have it negative I plus j minus 2k. So next, find the cross product by the expansion of determinant. We're going to have for the I component, which is 4 minus 4. For the j component, where we have it negative 4 plus 4. And for the k component, 2 minus 2. So it's end up equal with 0. So therefore you have to give the conclusion, since V1 cross V2 equal with 0, thus L1 is parallel to L2. Okay, next, part B. Find the angle between line 2 and line 3. So in order to find the angles between two lines, so you have to identify the V. So V2, we already have it from part A. For the V3, you have to identify from the line 3. So from the Cartesian equation, for the I component, we have it 2I. And for the J component, we have to simplify the function, which is, we're going to have negative y plus 1 in bracket. So negative we have to bring down. So your v for the j component will be negative 1. And then for the k we have 3. So your v3 will be 2i minus j plus 3k. So next you have to find magnitude for both vectors. For the magnitude v2 we get square root of 6. And then magnitude for v3 we're gonna have equal with square root of 14. Then find the dot product of v2 and v3. To find the angle, you have to substitute into the formula. And we have it, the answer, which is 169.11 degree. So I guess that's it for now. I will see you in the next part. Take care and bye bye.